Dear students, let's take some more example on integration. We are given with evaluation of I is integration of x upon x plus 1 dx. Here, this is slightly a tricky question. You can see, as we don't have any question rule and directly we cannot substitute something as no differentiation part is given. So here we'll just rearrange the result. Obviously, you'll get such tricks by practice only. It can be written as x plus 1 minus 1 upon x plus 1. What I have done, in numerator I have added 1 and subtracted 1. Now if I open it, this will become integration of x plus 1 by x plus 1 is 1 minus 1 by x plus 1 into dx. In this situation, integration of 1 is x minus integration of 1 by x plus 1. This can be taken as t, so it can be simply written as ln of x plus 1 plus c. So you'll directly get the answer. Here I've done direct integration of 1 upon x plus 1. I know integration of 1 by x is ln of x. Here if we talk about integration of 1 by x plus 1, here we can see even if we differentiate it, we are getting 1. So a linear function can be directly regarded as or as good as a singular variable. Like 1 by x or 1 by x plus 1, it is 1 and same. But it is not so for all linear functions. Like we can generalize this function in different forms also. Like if we talk about generalization of linear functions in integrands. This is also a very useful term. Like if we just generalize in this form, integration of ax plus b to power n dx is given to us. We know the formula of x to power n dx, that is x to power n plus 1 by n plus 1. Here it will be slightly different. Here we can write ax plus b to whole power n plus 1 upon n plus 1 into 1 by a plus c. Here whatever is the coefficient of x, we need to divide it. Because when you differentiate this function, you know well what you are going to get. It is ax plus b to power n plus 1. This will become n plus 1 ax plus b to power n. So n plus 1 will get cancelled out and then you multiply it with the differentiation of ax plus b, that is a. That a has to be cancelled out, that's why we divide it by a. Or you can also get it by substitution, like if we take t is equals to ax plus b, this implies we get dt is equals to a dx. Or we can write dx is equals to 1 by a dt. Now in this situation, what this function is going to become? It is integration of t to power n, as ax plus b I have taken as t, and dx I can write as 1 by a into dt. So you can see what we are getting is 1 by a into t to power n plus 1 upon n plus 1 plus c. Here we are getting this on. So in this manner we can generalize all integrands whenever in arguments we are having a linear function. Like number 2, you are given with the integration of 1 upon ax plus b dx. This can be written as ln of ax plus b and coefficient of x, which is a, we can use 1 by a plus c. Another form, say we are given with the integration of sine of ax plus b dx. You can always regard this as a single variable t. Sin t integration will be minus of cos of ax plus b plus c, but divide here by a, where a is the coefficient of this x. In this manner you can generalize all functions or all integrands which contain linear functions. Let's take up another example of a similar type. Say we are required to evaluate I is equals to integration of e to power 4x plus 7 into dx. This is also of same category which we have studied, but if we just integrate it by taking, let t is equals to 4x plus 7. You can see in this situation what we are going to get as dt. It will be 4 into dx, as differentiation of 4x is 4 only. Now in this situation, we'll see the value of I is equals to integration of e to power t into the value of dx can be written as 1 by 4 into dt. So it will be 1 by 4 as being a constant can be taken out of the sign of integration and multiplied by dt. So this will be 1 by 4 integration of e to power t is e to power t plus c. So this can be written as 1 by 4 e to power 4x plus 7 plus c. So you can directly integrate this also by using the concept of linear functions. Like here we are having e to power 4x plus 7, which is a linear function. If you just imagine this as a singular variable, say t, the e to power t can be directly integrated as e to power t, and in a linear function, whatever is the coefficient of x, we divide it as we multiplied by 1 by 4 plus c. This is the direct result. You can bypass this process also whenever you are having a linear function. So be careful about such situations also. Let's see one more example. If we are required to evaluate I is equals to integration of cos square x dx. Again, this is not in direct form, but cos square x can be accounted by using a trigonometric identity of double angle. I think in trigonometry you might have studied cos 2x can be written as 2 cos square x minus 1. So from here, if we calculate cos square x, the value will be 1 plus cos 2x by 2. So we can substitute this here, and here the value of this integral becomes integration of 1 plus cos 2x by 2 dx. So this can be written as integration of half plus half cos 2x dx. So integration of half will become half x plus half. If we talk about the integration of cos 2x, we know integration of cos x is sin x. So here if we take this 2x as a linear function, we can write integration of cos 2x will be sin 2x by 2 plus c. So our final result will become x by 2 plus 1 by 4 sin 2x plus c. So this will be the result of this integrand when it is integrated. If you wish, you can verify by differentiating this result. If we take one more example, if we evaluate I is equals to integration of sec 4x 10x dx. Again, directly we cannot integrate it. Here we take a substitution as let t is equals to sec x. Then we'll get dt as sec x 10x dx. So from this sec 4x we take one sec x out, and sec x 10x dx can be taken as dt. And if you take one sec x out, the remaining will be sec cube x, which can be written as t cube. So here the value of I will become integration of t cube dt. So in this situation, the integration of t cube will become t to power 4 by 4 plus c. If we just substitute the value of t here, it will be 1 by 4 sec 4x plus c, which is the answer to our case. Now we'll discuss some particular cases of trigonometric substitution. These are some particular type of integrations or integrands where we need to substitute a variable in trigonometric form. Like if we are given with I is equals to integration of 1 upon a square minus x square to power 3 by 2 dx. This cannot be directly integrated by any sort of substitution. Here we need a special substitution like let x is equals to a sin t. Here we put x as a sin t. Here you can also substitute x as a cos t, because when you put x as a sin t, this will become 1 minus sin square t. So it will become cos square t, and this radical sign can be removed. Here, if x we have taken as a sin t, dx will be written as a cos t dt. Now we substitute the values of substitution. It will be integration of 1 upon a square minus a square sin square t to whole power 3 by 2, and dt we can write, this dx we can write as a cos t dt, and denominator you can see it will become a square, you can take common, it will be a square cos square t. This integration of a cos t dt upon a square cos square t whole power 3 by 2. Here this 2 can be cancelled out and the whole can be taken as a cube root. Whole can be taken as cube. So this will be integration of a cos t upon a cube cos cube t into dt. At this a will cancel, cos t will cancel. This will be 1 by a square integration of sec square t dt. So now sec square t is in the form of direct integration. Here we can directly write the result as 1 by a square into tan t plus c. Now we need to substitute the value of t also, or we need to find the value of tan t, which we can obtain from here. Here you can see the value of sin t is equals to x by a. If we draw a right angle triangle with this angle as t, so sin t can be written as x by a. The base of the triangle will be a square minus x square. So if sin t is x by a, we can get the value of tan t, which is x divided by root of a square minus x square. If we put it here, the result will be 1 by a square. Tan t we just substitute as x upon root of a square minus x square plus a constant. This will be the answer to this question. So very carefully have a look on this process, because in physics at some specific cases we need to substitute this type of substitution. You need to be very careful about these cases.